All right, today we are taking a look deep inside the circulatory system of our industrial world. No, we're not talking about blood vessels. We're talking about the pipes and exchangers that are literally the lifeblood of everything from food production to power plants. But what happens when those arteries start to get clogged? And that's a huge question. Because, just like in our own bodies, when a vital pathway gets blocked, performance plummets, pressure starts to build, and, well, eventually you're looking at a catastrophic failure. So, how do you actually spot the problem before it's way too late? Well, it all kicks off with a diagnosis, learning to recognize the symptoms of a system that's in trouble. So let's meet our patient for today, the plate heat exchanger, or PHE for short. You can think of it as the lungs of an industrial process, constantly working to transfer heat and keep everything perfectly in balance. But like any vital organ, it's definitely vulnerable to, well, disease. And the main disease we're diagnosing here is something called fouling. It's really just the technical term for a buildup of all kinds of unwanted material. We're talking scale, sediment, biological slime, this gunk. Basically, it is the plaque in our industrial artery. The symptoms of fouling are pretty unmistakable, and they really show up in three key ways. First, you'll see thermal performance just drop off a cliff. The exchanger can't transfer heat efficiently anymore. Second, the pressure you need to push fluid through it starts to skyrocket. And third, the flow rate itself slows to a crawl. The whole system is basically struggling to breathe. Okay, so once you've got the diagnosis, it's time to prescribe a treatment. And the good news is, there are several proven methods to get these systems back to full health. Choosing the right approach here is absolutely critical. You've basically got three main options on the table. You've got plate removal, which is like major surgery. Super effective, but it means a full disassembly. Then there's back flushing. Think of this as a temporary fix, kind of like using a plunger. It might clear a small blockage, but it's not solving the real problem. And then there's CIP, or cleaning in place, which is really the equivalent of preventative care. And since prevent-a-care is almost always the best strategy for long-term health, we're going to focus on the most recommended regimen of all, cleaning in place, or CIP. So why is CIP the go-to? Well, it really all comes down to efficiency and longevity. It's the most economical way to keep things running at peak performance and to avoid that really expensive major surgery down the road. It really is the cornerstone of any smart maintenance program. Now, this slide breaks down the process beautifully. It's a very systematic procedure. First, you isolate the unit, then you connect the CIP system, and, now this is the really clever part, you circulate the cleaning solution in the opposite direction of the normal flow. This helps knock all those deposits loose way more effectively. After a few hours, you just drain, rinse, and the system's ready to go back into service. But, and this is a big but, CIP is not a silver bullet. It's so important to understand what it can't do. It's designed for scale and biological gunk, not for big physical blockages. So if you've got fibrous stuff like paper pulp, or big things like stones, or even shellfish in your system, and trust me, that happens, CIP is not going to work. That's a job for a full manual cleaning. Okay, now for what might be the most critical part of this whole treatment, the prescription. Choosing the right chemical cleaner is absolutely essential. I'm serious, the wrong choice can do way more harm than good and can permanently damage your equipment. I want you to really let this sink in. This is probably the single most important warning in this entire process. Using the wrong chemical, like hydrochloric acid on stainless steel, isn't just a little mistake. It is a recipe for incredibly fast corrosion and ultimately catastrophic failure. This isn't a suggestion. It is a hard and fast rule. Never, ever do this. And this slide breaks it down even more clearly. The material of the plate determines its chemical allergies, so to speak. For stainless steel, you have to avoid hydrochloric and hydrofluoric acids. For other materials like nickel or manel, ammonia and oxidizing acids are the enemy. The wrong prescription will literally eat away at the plates. So what are you supposed to use? Well, it all depends on the type of fouling you're dealing with. For mineral scale and sediment, you need a mild acid, something like citric or phosphoric acid. But for biological growth and slime, you'll need an alkaline cleaner like sodium hydroxide. It's all about matching the medicine to the specific ailment. Now let's talk about dosage, because more is definitely not better here. The key number you need to remember is 4%. That is the recommended maximum concentration for most of these cleaning agents. Using a stronger solution isn't going to clean it better or faster, it's just going to dramatically increase the risk of damaging the plates. So getting the dosage right is crucial. And right alongside dosage is temperature. The magic number to remember here is 80 degrees Celsius. You do not want to go above this. Pushing the temperature higher won't improve the cleaning. In fact, it can make some chemicals less effective, and more importantly, it can damage the rubber gaskets that seal everything together. All right, one last detail, and this is one of those things that's so easy to overlook but can totally sabotage the whole process: the quality of the water you're using. If your water has a high chloride content, anything over 300 parts per million, it can actually cause corrosion on stainless steel. So yeah, even the water itself is a key part of a safe and effective prescription. So after all these procedures and precautions, preventative maintenance might seem like a lot of work, but that brings us right back to our very first question. When you really think about the cost of unplanned shutdowns, lost production, and emergency repairs, what's the real cost of doing nothing? Turns out the health of these industrial arteries is more than worth the checkup.